Hey guys, I'm Catherine Schroeder, and I wrote my report on the evolution of the human mandible and teeth. And so a lot of that had to do with how the body evolved as well. So I'll be talking about the brain and some of the body bones, like the pelvis as well. So one term that I want to cover before I start is paleoanthropology, which is the study of human origins and evolution. So they use two terms interchangeably, which is a hominoid and a hominid. So hominoid refers to the group that contains the great apes and humans, and a hominid refers to branches of the evolutionary tree closest to humans. So there are two main groups of hominids. The Australopithecines, which came first and are now all extinct, and the members of the genus Homo, which are all the species except Homo sapiens, which are us. So before we start talking about how the mandible changed throughout evolution, I'm going to talk about some major features, which are brain size. Hominoids lived about 6 million years ago. Their brain volumes were about 400 to 450 centimeters cubed. And this is close to the volume of a modern day chimpanzee. And today, our brain volumes are about 1,300 centimeters cubed. So it's about a triple in size. And the second major feature is jaw shape. So hominoid ancestors of man had long, pronounced jaws. So they're very large, similar to a modern day gorilla. And they also had large zygomatic arches. So I am going to screen share this right here. So this is a picture of a chimpanzee skull and a Homo sapien skull. So on the left, you can see that at the top of their skulls, they have a indent, I guess you can say, and it's called a sagittal crest. That is something that us as Homo sapiens don't have, and that is a reason for why we have larger brain volumes. Also, our cheekbones, which are the zygomatic arches, are much smaller, and that has a lot to do with how the face changed and how the jaw got smaller. So let's end this screen share. Okay. So another thing to notice is this image of the teeth between the gorillas, the Australopithecus africanus, and humans. So we can see that the incisors, which are the first 4 teeth in the mouth, when looking at the mouth, they're the first 4 teeth you see. They are much smaller in humans, and also canines, the sharp teeth you see in gorillas and dogs, those are canines, and we don't have canines like that. Also, just the mouth itself is much smaller, and that has a lot to do with how our changes in food over time happened. And so a third point is the bipedal posture. So bipedal locomotion was something that we talked about in class, which had a lot to do with how trees were dying out. Hominids found that walking on 2 feet was a lot more energy conservative, and they could cover a lot more ground that way. So here's a picture of a pelvis that we talked about in class. We have much smaller pelvises than chimpanzees and the Australopithecus africanus do. And also our teeth, our foot bones are much more closer together. And for the reduction in size between males and females. So in hominoids, the size difference between males and females is a major feature, whereas in humans, it's not. It's about a 1.2 difference. So one species is the Australopithecus africanus, which was first discovered in 1924 in South Africa. They lived about 2 to 3 million years ago, and they walked on 2 feet, have human-like hands and teeth. So the Australopithecus amensis was discovered in 1995. They are one of the oldest known Australopithecines. Fossils found include parts of jaw bones, arms, leg bones, but they have not found a complete skeleton, so they're not quite sure where the comparisons are like, but they do seem more like an ape than to a person. So here's one of their jaws. As you can tell, it's when looking at the hand, it is much larger than the human jaw. And here, when looking at the elbows at the bottom of the page, you can see that they have an indent where the bones just lock together and there's not much room flexibility for the joints to move. Whereas in the human arms and elbows, there's just a crevice, like a smooth crevice where we have a lot of flexibility between our elbows. So the Australopithecus robustus is a species that had a very heavy, thick skull. So they're about the same size as the Australopithecus afarensis. They had large jaws and teeth, which were well adapted to chewing. They lived about 2.1 to 1.6 million years ago. So a species that was similar to them was the Australopithecus bozi, and they lived about 2.3 to 1.1 million years ago. And so the bones between both of the robustus species and the bozi species are interchanged, and they're not quite sure which go with which. But the Australopithecus bozi does have a skull and teeth that are much larger. Okay, and so some proposals for the evolution of hominids, there's 8. So the Australopithecus afarensis was the ancestor to both later forms of the Australopithecines and the Homo species. Scientists believe that divergence between the Australopithecus and Homo occurred between 3 to 2.5 million years ago. And so one branch led to the Australopithecus africanus, and then the more specialized Australopithecus robustus and the variant Australopithecus bozi. So the other major branch led to the Homo habilis, the earliest member of the genus Homo. So portions of the Homo habilis population gave rise to Homo erectus, and part of the Homo erectus population led to the development of Homo sapiens, which are us, and a whole new species on their own. So here we can see how the jaw size has evolved over time and the cranial space has evolved over time. So we can see that our jaws became much smaller and more parallel, and our brains became larger. So one thing to notice is that the parietal areas of the brain stayed the same, except for the occipital areas and the frontal lobe were what changed the most. And I guess when looking at also the temporal areas. And so the increase in brain size had a lot to do with the with bipedal locomotion and more complex thinking and speech and communication between species. And so a couple more proposals are that the modern man emerged as recently as 40,000 years ago. Examination of the trends in evolution indicate that not all organ systems have evolved at the same rates, and we know that just by looking at how animals have evolved. It has a lot to do with the environment, with the species, and with rivers, rain, snow, and stuff like that. And then the most important is probably the bipedal movement trait that appeared very early that scientists refer to as the main breaking point onto how we became us as Homo sapiens today. So, to sum up, basically, while I was studying the evolution of humans over time, I noticed that a lot of the changes happened progressively. So jaws progressively became smaller, teeth progressively became smaller as the brain progressively became bigger. And I think that has a lot to do with learning and how we adapted to things and we used our new traits to their fullest and how we became to what we are today. And so in my report, I also talk about the church's stance on evolution. And we all know that we were created in the image of God. And so, as said in Genesis, so I think this is all just how science puts how we evolved. And so I'll just leave what you guys think up to you guys, and I'll see you guys later.